Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2019, Paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a, here are some types of number: an even number, an odd number, a prime number, a square number, a cube number. From the list, write down the type of number being described. A number that does not divide exactly by 2. If you can divide it by 2, it's 2, 4, 6, 8. They're the even numbers, and the not even numbers are the odd numbers, aren't they? So it is the odd numbers. Oops. Part 2, a number that has no factors except itself and 1. In other words, it's got exactly 2 factors, and a number with exactly 2 factors is a prime number. Okay. Part B, part 1, write down all the multiples of 4 between 21 and 29. So if you think about the 4 times table, 4, 8, 12, 16, 20, then 24 then is in that range, isn't it? And then the next one, 28, and then we're over already, aren't we? Up to 32, which is beyond the end. So it's just those two, 24 and 28. Part 2 says write down a common multiple of 4 and 6. I think the easiest way of doing this is just listing out a few multiples until you hit one that's the same on both lists. So the first few multiples of 4 are 4, 8, 12, 16, 20. Just do a few and then switch to the other one. 6, multiples of 6 are 6, 12, 18. I think I've already spotted one already that's on both lists. It's 12, isn't it? Okay, so got 12 on both lists. So 12 is a common multiple, and it is actually the lowest common multiple. Part C, lots going on in question 1, isn't there? Insert brackets to make this calculation correct. Now without the brackets, I would be doing this bit first due to BIDMAS, wouldn't I? I'd do multiplication first. And 1 times 2 is 2, and then 4 subtract 2, that would be equal to 2. So as it stands, this is not correct, is it? It comes out to be 2. Okay. Now there's already an implied pair of brackets around this part. Okay, so it's not going to be that big because that isn't going to change anything. What happens if we put brackets around this part here? Then I'm going to get 4 subtract 1, which is 3, and 3 times 2. Well, that is 6, isn't it? So that works. Okay, so that's where the brackets need to go. It's 4 minus 1 around those. Okay, finally for part D, I need to write down 7% as a fraction. Well, percent signs mean, well, percent literally means out of 100. So 7% is 7 over 100. So that's it. That's our fraction. Job done. Question 2, work out 1.52 kilograms plus 80 grams. Give your answer in kilograms. So you'll notice here that we've got two types of unit. We've got grams and kilograms. They're both metric units, and we can convert between them quite easily, can't we? As 1 kg is equal to 1,000 grams. So if you've got grams and you want kilograms, you divide by 1,000. If you've got kilograms and you want grams, you times by 1,000. Okay? Now, my final answer needs to be in kilograms. So it might be sensible to convert the grams into kilograms first, and then we just need to add them up and write down the answer. The only disadvantage of doing that is that 80 grams in kilograms, you're going to get 0.08. Okay, so you'll be adding decimals. So it might be easier just to convert everything to grams first and then convert back again. Okay, depends how you are with decimals. If you're okay with decimals, it's probably quicker to convert to kg. Otherwise, convert everything to grams and then add it up, and then you can convert back again. So 1.52 kilograms, if you're going to take that and convert it to grams, you need to multiply it through by 1,000. So that's going to be 1,520 grams, isn't it? Okay, and then we're going to be adding on 80 grams. So then that becomes 0.006. That's 1,600 grams. And then it's very easy to convert back into kilograms. Just divide by 1,000. That's going to give me 1.6 kg, isn't it? And that's my answer. Okay. So like I say, I could have converted everything into kilograms and saved that converting back at the end. But actually, adding up numbers not as decimals is a lot easier. So that's probably the best way of doing it, I think. Question 3a, round 32,629 to the nearest thousand. Well, the thousands are this digit here, aren't they? That's the thousands. The 3 is tens of thousands, the 2 is thousands, 6 is hundreds. So I need to round off after that 2. That's the cut point. So everything after that cut line is going to get thrown away. But just before we do, we just need to check out the value of the next digit along, which is 6. And then if it's 5 or more, we need to raise the score. We're going to round up. If it's 4 or less, we need to let it rest. We're going to round down. And in this case, it's 5 or more. So I'm going to round this one up, aren't I? So my 32 at the beginning is going to go one up. It's going to go 33. Now, 33 is not a good estimate of 32,629. My rounded number has to have the same magnitude. That 3 at the beginning was tens of thousands, so we need to make this number tens of thousands again just by adding some extra zeros on the end. Okay, so just check your answer is the same magnitude as what it was to start with. 33,000. Next, we need to round 32,629 to one significant figure. Now, the first significant figure is the first non-zero digit of your number. That's the 3. Okay, so in this case, we're going to be rounding off right after the 3. Okay, now the next digit along is this time is a 2, which is 4 or less. So we need to let it rest. We need to round down in this case. Okay, so the 3 at the start is going to stay being a 3. And we're just going to then add on enough zeros to make our answer the same magnitude as it was to start with. So adding 4 zeros, I'm going to get 30,000. Okay. Another way of thinking about it is the first significant figure is in the tens of thousand column. So just round your number to the nearest 10,000. So you can see that 32,000 is closer to 30,000 than 40,000. Question 4. A circle has radius 5 centimeters. Work out the circumference of the circle. Okay, so I've got a circle. Radius is the distance from the center to the edge. That's the radius. So this has got a radius of 5. Okay, so then to work out circumference, cherry pie delicious, apple pies are 2. Okay, then my 2 formula for circles. Cherry pie delicious, circumference equals pi times diameter, area, apple pies are 2, area equals pi times r squared. It's just a silly way of remembering it. So cherry pie delicious, apple pies are 2. Now in this case we want circumference, don't we, which is this one. But this one it's in terms of d, isn't it? There's another way of writing this. There's two approaches here. We could just work out what d is. D is 2 lots of the radius. It's going to be 10, isn't it? It's going to be twice as long as the radius. Or you can use 2 pi r as well. That's another formula you can use. Okay, I'm just going to convert or find d. D is 10. Diameter that is, and then sub it into my formula. So c equals pi d equals 10 lots of pi then, isn't it? So pi is 3.14, so that's just going to be 31.4 what? 31.4 centimeters. It's just in flat units, isn't it? So 31.4 centimeters, you could do that on your calculator. I just happened to know that pi was 3.14, so it just saved me typing it in. Work out the area of the circle. So we did the circumference one first. Now it's time to move on to the area one. Area equals pi r squared. Apple pies r2. Then subbing in, this time r is 5, so it's going to be pi times 5 squared, isn't it? So 5 squared times pi, which is 25 pi. What's that? Tap that into the calculator. So 25 times pi. You've got a little pi symbol on your calculator, so just use that. So that's 78.5 and change according to my calculator. Just going to round it off to 3 significant figures. 78.5. Question 5. Dan thinks of a number. He adds 3 and divides the result by 2. His answer is 16. What is the number that Dan is thinking of? Okay. Now this is actually an algebra question. And the reason it's for the algebra question is because when Dan thinks of a number to start with, we don't know what it is. And we have to do a whole bunch of things to this number that we don't know. And then we're told the answer. So basically, what we need to do here is form and solve a linear equation. Okay, using a bit of algebra. So we're going to say, let Dan's number be x, because why not? We always use x, don't we? In maths. So we take Dan's number, which is x, and we add 3 to it. So x plus 3. That's adding 3 to x. And then we divide the result by 2. So I'm going to draw a division line all the way across. So everything there divided by 2. Okay, and then the answer is 16. So that is equal to 16. Okay, so I formed my equation in x now. Now I just need to solve it. Okay, can you see I've got x plus 3 divided by 2. Okay, so normally we go through Bidner backwards when we're unwinding equations like this. So you might be thinking that you have to deal with the adding first and then the division. But in this case, that divide sign goes all the way across the bottom of your expression on the top. So there's a kind of implied pair of brackets here. Okay, changing the order of operations so that the x plus 3 happens first and then you do the division. So then working backwards, you're going to do the opposite of the division first and then the opposite of the addition. So the opposite of the division first, dividing by 2, that's the opposite of timesing by 2. So if I times both sides by 2, this will cancel with this. And 16 times 2 becomes 32. So I get 32 on the right. On the left, I'm just left with the numerator of my fraction, so x plus 3. Okay. Next step, I want to get x by itself, remember. So the opposite of adding 3, that is subtracting 3. So taking 3 away from both sides. Those two things disappear. Now that is going to leave me with x on the left. 32 take away 3, that is 29. X is 29. Now at this point, you might just want to double check by running through the thing. So let's say that Dan thought of 29, he added 3 to it. What's 29 plus 3? That is 32, and then divides the result by 2. 32 divided by 2 is 16. His answer is 16. Okay, so it works. So at that point, it's always a good idea maybe just to sub back in and check that it does actually work out. It does. Let's move on. Question 6. 30 students each own one pet. The pie chart shows the proportion of each type of pet owned by the 30 students. So they own a range of different things here. Quite a few of them own horses. That's weird. Not surprisingly, rabbits, mice. I think that's a bit weird. Cats, dogs, they're all fine. Okay? Cats, dogs, rabbits, that's all fine. Mice, no. Horses, well, okay. If you fancy galloping around and stuff. All right then. So anyway, what type of pet is the mode? Mode in maths means most, and the most huge section, or the biggest slice of the pie chart, is cat, isn't it? You're going to see that with your eyes. The cat is the biggest slice, and therefore that is the mode. So cat is the mode. Part B, use the information in the pie chart to complete this bar chart. So we've got two bars written already. Rabbit is at a height 3 and cat is at a height 12, but we're missing the mouse, dog and horses, so we need to know how many students that was. So we're going to have to go back to the pie chart and work some stuff out first. So coming back to the pie chart, so we know rabbit is 3 and cat is 12. So let's just write that on the diagram before I forget. So that's 3 and that is 12. Okay, I think what I'm going to do is I'm just going to do a table of values. I'm going to say pet, type, I'm going to say frequency and angle. Okay, so if I quickly do this table, now often when you draw a pie chart you're given this table and you have to kind of draw it, don't you? But here we're going to work backwards. Okay, so we've got rabbit, mouse, cat, dog, horse. Okay, now we know the frequency already of rabbit and cat. That was given. So rabbit was 3, cat was 12. And we know most of the angles, don't we? They've been given at the center of the pie chart. So the angle for rabbit was 36. The angle for mouse was 24. The angle for cat is 144. The angle for dog isn't been given, but the angle for horse is 72. Now I think what we need to do is we need to complete this table, don't we? We need to know the frequencies of mouse, dog and horse. So if we can complete this table, we can then do the bar chart. Okay? Right, so now you should know that angles in the circle always add up to 360. So that's probably a good place to start. If we say that adds up to 360, then we've only got one missing, haven't we? We've got the dog one that we need to find. Okay, so if all those things add up to 360, then the dog one, if we called it x, that would be all of those other ones taken away from 360, wouldn't it? So like 36, 24, 144, 72 and x all need to add up to 360. Okay, and so what do they add up to? Let's just get my calculator out. So 36 plus 24 plus 144 plus 72. So that comes to 276. So my x value plus 276 is equal to 360. So then taking 276 away from both sides, then that's going to leave me with x, isn't it? Because they're going to cancel off, leaving me with x here. So x is going to be 360 minus answer, that's 84. Okay, so now I know that that is equal to 84. Okay, now I've got the complete picture. Right, now how can I work out the frequencies? Now that I've got all the angles, how can I work out the frequencies? Well, can you see a pattern between these numbers? Between the 3 and the 36, they go together, and between the 12 and the 144. If you think about it, 36 divided by 3 is 12, isn't it? So coming from this number to this number, it would divide in by 12, and the same is true here. If we divide 144 by 12, we're gonna get 12. Okay, so that means we can work out the frequencies by dividing the angle by 12. Okay, mouse was 24 degrees. Divide that by 12. That is going to be 2. Dog was 84. Dividing that by 12, that's 7, isn't it? And then 72 divided by 12, that is 6. Okay, so we got 3 for rabbits, 2 for mouse, 7 for dog, and 6 for horse. Now we've got all those, we can now draw the chart, can't we? Okay, so coming back to the chart, we need to draw some bars in here, don't we? So time to get the old ruler out. So the mouse bar is going to be at height 2. With the bar chart, your bar should not be touching. There should be a nice gap between your bars. So the mouse is there, dog is at 7, and horse is at 6. Okay, so I'm just going to spin the rule around and then draw the sides of my bars now. Okay, now it's not normally necessary to shade them, but if you've got like a super faint pencil and they're hard to see, no harm in just checking them like that so they stand out a bit more. Okay, good job. Question 7. Jenny has a 5-sided bias spinner. The sectors are coloured red, blue, green, yellow and white. She spins the spinner 100 times. The table below shows the number of times the spinner lands on each colour. So the colours are red, blue, green, yellow and white, and you can see that they've landed on various colours various numbers of times. Jenny uses her data to estimate the probability of the spinner landing on each colour. Write down Jenny's estimate of the probability of it landing on red. Okay, so you can work out like a practical version of probability. We call it relative frequency. By taking the number of successful trials, which is in this case 28 for red, and dividing it by the total number of trials, which in this case is 100. So 28 divided 100, that is 0.28, isn't it? And so that is a rough and ready approximation of the probability of landing on red. Now obviously with 100 trials, probability being as it is, it might, the actual true value might be slightly more, slightly less than that, but it's going to be close to it. Okay, for part B, Jenny then writes in some of the colours on this probability scale. So she's written in yellow at 0, which is correct. Look, because yellow there were 0 outcomes out of 100. So it's hard to believe there was any yellow on there if none of them came up in 100 throws. So yellow is pointing at 0, which is impossible. Now the next one along is between unlikely and evens. If you think about this scale, there are how many jumps between one end and the other? So there's 1, 2, 3, 4, 5, 6, 7, 8. So each one of those is an eighth, or quarters in between, aren't they? So unlikely, that's at 0.25, that's at 0.5, that's at 0.75, and that's at 1. So this arrow is pointing somewhere between 0.25 and 0.5, and it's actually closer to 0.5. Well, halfway between 2.5 and 5 is about 0.37. So I'm guessing that must be the blue one then, mustn't it? Because the other two, the red and, well, the other three, the red, the green and the white, are going to be further down. They're going to be below, well, just a little bit above the 25, aren't they? 0.25, not all the way up here. Okay, so this one I think is going to be the blue one. Right, explain why Jenny's estimate for the probability of landing on yellow cannot be the actual probability. Well, if you remember at the start of the problem, it was described as a 5-sided spinner, bias spinner, so it's kind of weighted to one side. So when you spin it, it's more likely to land on one of the other colours than it is to land on yellow. But presumably, if yellow is one of the kind of corners of your spinner, if you think about the spinner, so it's kind of, maybe it's got like a weight on this side, which means if you were to spin it, it's more likely to fall this way. But you know, if yellow was over here on this side, it's going to be less likely to land on it, but it's not going to be impossible, is it? Okay, it's just going to be very, very unlikely, which is why she hasn't rolled on it already. I'm guessing that's the sort of answer they're looking for. So cannot be the actual probability. 0 would imply that it is impossible to get yellow, but as it is one of the sides of the spinner, it must be possible likely to land on it. Okay, so that's my reason. Okay, so it didn't land on yellow in any of those because it does favour the other colours quite strongly, but presumably, you know, if there's some sort of freak wind, it might just kind of fall over onto the yellow at some point. Question 8a, shape G is drawn on the grid. Yes, it is. Rotate the shape G by 180 about the point A. Now, I do recommend at this point you put your hand up in the air and ask the invigilator, if this was an exam, for a piece of tracing paper. And then you can just simply lay the tracing paper over the shape like so. I normally put a dot in each of the corners of the shape first. If you feel like it, you can then join them up with a ruler, but maybe it's not necessarily. Maybe you just rotate the piece of paper around with just the corners on, and that's where your new corners will be. Just as a top tip, I like to put like an X across at the center of rotation. And the reason for I do that is because as I rotate it around, I can see when I've turned 90 and 108 degrees. And so I know when to stop, okay, which is there. Okay, I'm going to stop there. And then so you can see where my new points are going to be. And then I can just kind of lift the tracing paper up a little bit and drop it down again and kind of work out where I need to put my points. So one of them is going to go here. One of them is going to go here. One of them is going to go here, and one of them is going to go here. Okay, and once you've got them all down, you can then get your ruler out and join them up. Do we need to label it anything? No. I'm just going to call it G dash because it's like the image of G. Okay, it doesn't tell me to label it, but they often do, so I just kind of label them anyway. Right, let's move on. Part B, shape H is drawn on the grid. Enlarge shape H with a scale factor of 2 and the center of enlargement at the point B. Okay, so when you've got a shape with a center of enlargement, then you can work out where all the other points go by drawing ray lines through each of the corners of your shape. Okay, so I'm just going to draw line going down here, line going across here, and a line going down here. Now the image point of your enlargement are just going to lie further along those ray lines. So this point B lies on the center of enlargement, so that isn't going anywhere. If a point lies on the center of enlargement, it's not shifted at all by the enlargement, it just stays where it is. Okay, now this next point over here, that I hope you can see is 1, 2, 3 units away from the center of enlargement. Now the scale factor is 2, so I need to multiply that distance by a factor of 2. So rather than it being 3 units away, it's going to be 6 units away from the center. So we've already gone 3, so that's 4, 5, 6. So the point is going to end up there. Okay, that's where the new image point is going to be. Let me just get rid of these jumps. Okay, so it's not messing up my diagram. So that's one of my points. So one of my original point at B is staying at B. Then I've got a point at that point over there. Let's have a look at this point down here then. Oops. Let's have a look at this point down here next. Okay. Now this point lies like 1, 2 units down and 1 across from the center of enlargement. So if you were going to double that distance, rather than being 2 down and 1 across, it's going to be 2 times 2. It's going to be 4 down, and 1 times 2, it's going to be 2 across. So it's going to be here on the ray line. Okay, so it's twice as far away. Another way of thinking about it, look, that diagonal line and that diagonal line are the same, so it kind of works out, doesn't it? Okay, so that's where the point is. Again, we're going to get rid of these extra dotty dots that I drew, just so I keep the diagram tidy. And then finally, I've got this point here on my diagram. Now that is 1 unit down, 2 units down and 2 units across. So its image point is going to be 2 times 2 is 4 units down and 4 units across. It's going to be here. Okay, so now I've got all of my corners mapped out. I can now join them up with straight lines. And again, don't try and enlarge the lines, enlarge the dots. This is the way. Now once you're done, you should know, it should look right, shouldn't it? Your new shape should just be like a bigger version of the shape you had. If it looks different, you've done it wrong. Okay, so just use your eyes at the end to double check what you've got looks just like a bigger version of the shape you started with, which mine does. Okay, it's a trapezium, it's still a trapezium, it's still just a bigger version of that same shape. Okay, I'm done. Question 9, Tom buys a radio for £40. Later, he sells it and makes a profit of 20%. Tom says, the ratio of the price I paid for the radio to the price I sold the radio for is 5 to 6. Show that Tom is correct. Okay, so I'm going to do the percentage increase. So if he made a profit of 20%, then he sold it for 20% more than he bought it from, isn't he? So I'm just going to do like a percentage increase first. To work out the cost and then show that the ratio of that with the original cost simplifies down to 5 to 6. Okay, so I'm going to start off with the triangle FOM, stick your thumb on it, which is the thing I like to use for doing my percentage questions. If you've seen any of my videos before, I'm sure you've seen this lots of times. So F stands for final, O stands for original, N stands for multiplier. So looking through the question, the final is the thing we're trying to find, isn't it? We don't know that one yet. That's what we're trying to find after the percentage increase. The original, what was the starting value of the radio? It was £40. Okay, so the radio started off being £40. The multiplier, what is the multiplier? Well, the multiplier is going to be an increase of 20%, then, isn't it? Okay, so you start off with 100%. If I increase it by 20%, then I've now got 120%, which is a multiplier is 1.2. Okay, so I'm going to use a multiplier of 1.2 and original of 40 to find the final. Okay, I'm using the triangle, cover up the thing I want to find. I want to find F. That tells me what to do with O and N. They're on a line, so that means I need to multiply them together. So final equals original times multiplier. Which is 40 times 1.2. So on my calculator, 40 times 1.2, that comes out to be £48. Okay, so he sold it for £48. Okay, so we need to see the ratio, the price I paid for the radio to the price I sold the radio. So basically, that's the original price to the final price, isn't it? Okay, so the original price, if you remember, was 40. We've just worked out that the final price was 48. Does that cancel down? Well, 40 and 48 are both divisible by 8. They're both in the 8 times table, aren't they? So dividing both sides by 8, divided by 8. 40 divided by 8 is 5. And spookily, 48 divided by 8, that's going to be 6. Okay? And that's what we needed to do. We needed to show that the ratio is 5 to 6, and we have it, it's there. So, shown. We did it. Question 10. Nada is planning the colour scheme of her bedroom. The colour of her carpet can be blue, grey or red, and the walls can be painted yellow, white or pink. Complete the table to show all the possible colour combinations she could make. You may not need all of the rows. So we're starting off with carpet as B, which is the blue one, and walls yellow, which is the Y one, aren't we? Okay. So when you're doing these lists, you need to try and be systematic. So what I try to do is I keep one thing the same and then kind of rotate through the other ones. So because B is in the first column, that's the one I'm going to keep the same for now. So blue carpet can go with yellow walls, or blue carpet can go with white walls, or blue carpet can go with pink walls. Okay, now that's all the possibilities that involve blue. Okay, so now I've kind of exhausted all the B's. I'm going to move on to the next color of carpet, which is G. And then I'm going to cycle through those 3 colors of walls again. So in the same order, so that I'm kind of being systematic. So I had yellow W, Y, W, and P before, so I'm going to do the same thing. So green with Y, green with W, green with P. Okay, so then once I've done all the greens, then the last color then is red. So I'm going to do red, and then I'm going to cycle through my 3 colors again. So red, yellow, red, white, red, pink. Okay, and that's it, isn't it? That's all the possible combinations. So I didn't need to use the whole table. That's it. So I've completed the table. That's all I had to do. Good job. Question 11, multiply out A, which is 3 lots of x minus 2. So when you've got a pair of brackets like this, everything on the inside of the brackets gets multiplied by that thing on the outside. So first off, we're going to multiply x by 3. That's going to give me 3x. Next, we're going to multiply negative 2 by 3. That's going to give me negative 6. So the answer is 3x minus 6. Okay, similarly with the second one, I'm going to multiply everything inside the bracket with that 2a. 2a times a, that is 2a squared, isn't it? 2a squared. And 2a times b, that is just 2ab. Okay, so that's it. That's done. Question 12a, find the value of the cube root of 216. Now I know the cube root of 216 because I memorized the first 10 cube numbers because they come up a lot like this. I know the answer is 6. If you didn't know the answer was 6, you can type it into your calculator, can't you? So you can type in the cube root button and just double check that it comes out to be 6. It comes out to be 6. 2 to the power of 8. Now again, you could do this in your head. It's quite easy. Just double, you know, 2, 4, 8, 16, 32, 64, 128, 256. It's 256. But again, quick to just put it on your calculator. Just type in 2 to the power of 8. It's going to give you that number straight away, isn't it? 256. Right, then part B, the cube of 3 is added to the square root of 7. Put a ring round the correct statement. The cube of 3, well that's 3 cubed, isn't it? The cube of 3 is 3 cubed, is added to the square root of 7. That's the square root of 7, and they're added. So it's 3 to the power of 3 plus root 7. Which one's that? It's that one. Okay, so that's what I need. 3 cubed plus root 7. Now, question 13. The midpoints of the side of the rectangle are joined by straight lines as shown. Work out the percentage of the rectangle that is shaded. Okay, now, when students see these sort of things, they panic because there are no numbers anywhere. How can you work it out with no numbers? Okay, well, you don't really need numbers. You can just divide it up. Okay, if I get my ruler out and start attacking this shape, you may be able to see what's going on here. If I draw a straight line between there and there, these 2 points here are the midpoint, aren't they? Okay, so that line cuts my rectangle exactly in half, and I can do the same this way. Okay, that cuts the rectangle exactly in half. Now, hopefully you can see that this bit here is a quarter of the rectangle, isn't it? It's all one complete quarter. Now, a quarter in terms of percentages, what's a quarter? A quarter is 25%, isn't it? A quarter, half of 100 is 50, half of 50 is 25. So this represents 25% of my shape. Okay. Now, similarly, this is also going to be 25% of my shape. Okay. Now, in this section here, this is going to be 25%, all of it, but it's been cut in half, isn't it? It's half shaded and half not shaded. So this shaded bit here is going to be half of a quarter. It's going to be an eighth. Okay, so this is an eighth of the shape, and half of 25%, well, half of 25 is 12.5, isn't it? So that is 12.5%, and so is this one over here. The other way of thinking about it is that you could pick up this one I'm writing in now, and it would fit into that square down there. That's another way of thinking about it, and make 25%, wouldn't it? Because this bit here would fit in there, complete in that 25%. So you get 25%, 25%, and 25%, which is 75%. But the way I've done it, let's just get rid of these lines because they're bothering me now. Yep. So the way I've done it, I've got 12.5, let's just add them up, 12.5, 25, 25, and another 12.5, and you can see they add up to 75%, don't they? Okay, so what is the percentage of the rectangle that is shaded? It's 75%. That's it. Question 14a, 3 lines meet at a point. Work out the size of angle A. Well, angles at a point sum to 360 degrees. That's one of the angle properties or angle rules that you need to know. So those three amounts, all those three angles here, this one, and this one, when I add them together, that is going to give you a complete circle, isn't it? Okay, which is 360 degrees. So mathematically, that's A plus 103 plus 100, that is equal to 360 degrees. Okay, so adding together the two angles first, I've got A plus 203 is equal to 360, and then taking 203 away from both sides, 203 away from there, what am I left with? A is equal to 360, take away 203, that is 157 degrees. A is 157. Part B, X, Y, and CW are parallel lines. We're told that AB equals CB and angle CAX is 130 degrees. Complete the sentence. Angle CAB equals 50 because. Okay, why because? Okay, let's go back to the diagram and see what we've got. Now originally we were told that X, Y, and CW are parallel lines. So XY is here, CW is here. These are two parallel lines. So that means that this line here and this line here, these are what we call transversals. Okay, so that all the rules about angles in parallel lines are going to apply to those. On top of that, we've got this statement here, AB is equal to CB, and that tells me that this side here is the same as this one, and therefore triangle ABC is an isosceles triangle. So triangle ABC is isosceles. Okay, so it's isosceles. Okay, does that help me? I don't know, let's find out. Now, angles on a straight line add up to 180 degrees, so I should know what that angle there is because 130 plus it should be 180. Okay, so this one here, this angle here, is going to be 180 minus 130, and that is equal to 50 degrees, isn't it? Okay, so that angle there is 50 degrees. Now, because this is an isosceles triangle, then this angle here is the same as this one, isn't it? They're both 50 degrees because the base angles of an isosceles triangle are equal to each other, so that one there is 50 as well. Okay, is that what I need to do? I didn't even look. Angle CAB is 50 because angle CAB is 50, and we went too far. Angle CAB is 50 because angles on a straight line sum to 180 degrees. Okay, so that's the first thing I did when I worked out what 50 was. Angles on a straight line sum to 180 degrees. Work out angle BCW. BCW. Where's BCW? BCW is this one up here, isn't it? BCW, so it's that one. I need to work out this angle here. Okay. Well, I can use the properties of the parallel lines to help me. This angle BCW, it's actually what we call alternate to this angle here, isn't it? Which is ABC. So we can say that, well, so those two are alternate, so they're equal to each other. And what is that angle there? Now that is the tip of my isosceles triangle, isn't it? So that angle there, which I'm going to call angle ABC, that is equal to 180 minus the two other angles, 50 plus 50, which is 100. 100 take away from 80. That leaves me with 80. So this one here is 80 degrees. Now with these sort of questions, you'd always really write down the rule that you use. So here I used base angles in an isosceles triangle are equal. Okay, so that's the rule I used there. Base angles in an isosceles triangle are equal, and that gave me ABC is equal to 80. And then once I got that, I can use the fact that BCW, angle BCW, equals angle ABC, which is 80 degrees as well. And the reason for that is that they are alternate angles. Okay, so I've given my two reasons. Question 15. Ryan shoots an arrow at a target. He then kicks a ball at a goal, as you do. The probability that Ryan hits the target is 2/3. The probability that Ryan scores a goal is 3/5. Complete the tree diagram. So this is an independent problem, isn't it? Where the probability of him scoring the goal is not influenced by the probability of him hitting or missing with his arrow. So that means I can work out this one down here. 2/3 and 1. That needs to be 1/3 because these two add up to 1. You've got to have completion, haven't you? So if it's 2/3 up here, then this one has to be 1/3. So between them, you've got 3/3, and that's all the possibilities. So the probability then on the next part here for the goal is going to be he scores a probability of 3/5, which means he misses with a probability of 2/5. So again, you've got 5/5 altogether. As I said earlier, this is independent of whether or not he hits and misses the target, which means the probabilities down here on this section are just identical. Okay, so it's going to be 3/5 and 2/5 as well. Okay, that's it. We've done our tree diagram. It's all complete. Part B says, find the probability that Ryan misses the target and does not score a goal. So which route is that then? Going through this diagram, misses the target and doesn't score. So like that's ultimate embarrassment, isn't it? So the probability of a miss followed by a not score, what's that then? That is going to be, well, let's just follow that route down. If you follow the green route down, you hit the 1/3 first. That's the probability of missing. And I'm going to, because it's and means times in probability, I'm going to times by 2/5, which is probability of not scoring. So top times top, bottom times bottom, that is 2/15. That's the probability I want, 2/15. Okay, and then I've got part 2. It says, what's the probability that he either hits the target or scores a goal or both? Okay, well, hits the target is this route or this route. It doesn't matter if he hits or he scores or not, doesn't it? So if he hits the target, that's good. Or he scores a goal, that's also good. So the only thing, basically, that's the probability of not the first one. Does that make sense? So we can say the probability of either hit or goal. So I just noticed I've kind of fallen off the edge of the page a little bit there. Let me just pull it back in a little bit. So the probability of either hit or goal, then it's going to be all the other options, isn't it, that I haven't worked out already. So I could work out all those three things and add them up. But actually, because that's every other option, I can just say it's 1 minus the probability then of the one I've already worked out. Okay, because those 3 plus the other one should add up to 1 because that's all the possible outcomes. So I'm just going to say that's equal to 1 minus 2/15, which is, well, 1 is 15/15. Take away 2/15. That leaves us with 13/15, doesn't it? Okay, so that's the answer, 13/15. Now you could work it out. You could have multiplied out all those things and added them all up. But wow, that's a lot quicker. Let's do it that way. Question 16, solve the simultaneous equations. 2x minus y is equal to 7. 2x plus y is equal to 5. Okay, so I've got a pair of simultaneous equations. Let's call this one equation 1 and equation 2. Now when you're trying to solve these, what you're trying to do is eliminate one of the variables, either x and y first, solve that, what's left over, and then sub back in and find the other one. Now sometimes it's a matter of you have to kind of multiply up one or the other to try and cancel them out, but this one is very simple. All I've got to do is add these two equations together, because can you see I've got a negative y and a positive y. So if I add one equation to the other, then the y's are going to cancel out and it's just going to leave me an equation in x. So just kind of adding up along this column. So I'm going to go add those together, going to add those together, going to add those together, and right underneath. So first off, 2x plus 2x, that's 4x, minus y plus y, they cancel each other out. I don't get anything left over from that, so that disappears. And then I've got 7 plus 5, that's equal to 12. So I've got 4x is equal to 12. Then all I've got to do is divide both sides by 4. That's going to cancel, leaving me with x. 12 divided by 4 is 3. Okay, so I've already got x is 3. Now it's a matter of finding y. Okay, now what we have to do is then take one of the equations. It doesn't really matter which. I'm just going to take the second one though, because substitute x equals 3 into equation 2. Now the reason I picked 2 is because y is positive basically. So I can say that 2 lots of x, 2 lots of 3 plus y is equal to 5. Okay, so y was already positive, so I don't have to move it over to the other side to make it positive. I can just move the number and y is already where it needs to be. Okay, so 2 lots of 3 is 6. 6 plus y is equal to 5. Subtract 6 from both sides. That's going to cancel. Leaves me with y is equal to 5 minus 1, and minus 6 is minus 1. Okay, so x is 3 when y is minus 1. That's my solution. Question 17. Two model cars A and B are in a race. They start together on the starting line. Assume each car travels at a constant speed. Car A takes 30 seconds to complete each lap of the track. Car B takes a whole number of seconds to complete each lap of the track. The two cars next cross the starting line together 150 seconds after the start of the race. Find the 4 possible times that car B could take to complete one lap. You may find this information helpful. Ooh, now this is an interesting question. Where to begin? So I'm going to read that again because I am well confused. So A and B, model cars, blah, blah, blah. They start the race together. Car A takes 30 seconds to complete each lap. Okay, so they're going around in circles, aren't they? They're going around like a lap. They're starting together, A and B, and then A takes like how long does that take? So A takes 30 seconds to go all the way around. So A equals 30 seconds to go all the way around, and then what's going on with B? B takes a whole number of seconds. Oh, whippity doo! Thanks for telling me that. To complete each lap of the track. The two cars next cross the starting line together 150 seconds after the start of the race. Ah, okay. So, what does that mean? So we know by then that A has gone round. So if, A is going around every 30 seconds. So after 150 seconds, A will have done how many laps? 150 divide by 30, then A is going to have done 5 laps then, isn't it? So that counts with that, leaves me 5 laps. Okay, so A will have done 5 laps in that time, okay, in that 150 seconds. But what about B? What's going on with B? So B must have done a whole number of laps then, because again, if we take B, we need to take B and we need to divide it by a number and get a number of laps, and it's got to be a solid number of laps, isn't it? So the time B takes needs to divide into 150 and give a a whole number of laps, isn't it? Now, having a look at the information that's been given, these numbers are expressed as a product of their prime factors, aren't they? So I've got 150 is equal to 2 times 3 times 5 times 5, and 30 is equal to 2 times 3 times 5. Now you can derive these with those little factor trees, or there's a button on your calculator that you can press in order to work these out. But in this case, they've given it to us. But do you notice something? And so we said if we took 150 and divided it by 30, we'd get 5. 30 here has been expressed as 2 times 3 times 5. Now, if I took that out of here, look, you see there's that 5 left over. So 2 times 3 times 5 is 30. So if it divided by into 150, then those three things would disappear and it would leave you with the number on the end. Okay, so presumably then, if we could work it out another way, we could then say, well, so if I take my 150, which is 2 times 3 times 5 times 5, then before we saw that 30 was that, it leaves us with 5. What about if we took another combination of those things? So what about if we took those three things and left the 2? So it could be that B had done like 2 whole laps, in which case it would have taken him 3 times 5 times 5 number of seconds then to do his laps. So 3 times 5 times 5, that is 5 times 5 is 25 times 3 is 75. So he could have done a 75-second lap, in which case he would have done 2 laps. Okay, so that's one combination. Can we make any other numbers out of this? I suppose we could have also you know, done, if I take that one away, and that one away, I can leave the 3 then, can't I? I can say, well, that would be 3 laps, and it would take 2 times 5 times 5 seconds. So what's 2 times 5 times 5? So 2 5s are 25 times 2 is 50. So he could have done 50-second laps, in which case he would have done 3 laps in that time. Okay, so that's another possibility. Does it say that they're not traveling at the same time? Because they could be traveling at the same time, at the same speed, couldn't they? If they were traveling at an identical speed, then B could do that as well, couldn't it? So 2 times 3 times 5, which is equal to 30. He could be doing 2 times 3 times 5, which is 30-second laps, in which case he would have done 5 laps. So that's 3 possibilities. We just need one more possibility now, don't we? One other possibility, well, we don't have to pick 3 of these. We could maybe pick 2. So what about if we did 2 times 3 times 5 times 5? Let's say we picked those 2 at the end, 5 times 5. So he's doing 25-second laps. So 5 times 5 is equal to 25-second laps. And that would leave 2 times 3. That would be 6 laps. Okay, so there's 4 possibilities. Now, having thought about it, it can't be this one, because if they were going at the same speed, then they would keep meeting up at the same time. They would meet up every 30 seconds, so that isn't a possibility, so that can't be a thing. But I suppose the other thing that could happen is that he could have just done 1 lap. So if you multiply all of them together, so 2 times 3 times 5 times 5, if I multiply them all together, I'm going to get 150, aren't I? So he could have done 2 times 3 times 5 times 5, so that's 150 seconds, in which case that's 1 lap, isn't it? Okay, so what's the 4 possible times per lap then? 150 seconds, 75 seconds, 50 seconds, not 30, because he would be meeting up with his buddy more soon than that, or 25. I think they all work, don't they? So 25, 50, 75, 150 is my answer. Question 18a. Write down the multiplier for an increase of 140%. Give your answer as a decimal. Now, don't be fooled in thinking it's 1.4. If you're doing an increase of 140%, remember you always start on 100%. So if you're then increasing by 140%, actually you're looking for 240%, which as a multiplier is 2.4. Okay, so 2.4 there, not 1.4. Ali invests £1,500 in October. The investment increases at a value of 10% in November. It then decreases in value by 20% in December. Ali says 10% minus 20% is minus 10%. So £1,500 has lost exactly 10% of its value. Explain why he has done wrong. That's not how percentages work. Okay, and the reason for that is you've got additional money in your bank in November that you didn't have in October. So you you're going to be applying interest to a different amount. Okay, let's work it through. So in October, so in the month of October, he has got £1,500 in the bank. Yeah. Then the investment increases in value by 10%. So we're going to increase it by 10%. 10% of 1,500, that's 150, isn't it? So it's going to go up to 1,500 plus 150, that's 1,650. Okay, so then in November, he's going to start off with that amount, 1650. Now this time we're taking 20% off. Now 20% of 1,650, if 10% is 165, then 20% is going to be 165 times 2, isn't it? 165 times 2. So what's that then? £330. Okay, so we're going to be taking £330 off at this point. So taking that £330 away, that is 1,320 then, that we're going to get at the beginning. So that's the amount we've got in December then, isn't it? It's 1,320. Okay, now if we'd have just taken 10% off, so let's say if we subtract 10%, as Ali suggests, we would get 1,500 minus 10%, 150. We would get 1,350, wouldn't we? Okay, but the correct amount is 1,320. Okay. Now, probably it looks like that's only one worth 1 mark. I've probably well overkilled that question then in that case. Maybe they're looking for something more simple. So as it's only worth 1 mark, probably you can get away with just saying, you know, you're finding percentages of different amounts, and therefore they aren't the same. Maybe they just want a more kind of general answer there. Okay, I did it fairly specifically. I worked out what it was and I showed it was different. Which I think is good, but you know, I've clearly done much more work there than I needed to do to get that mark. Okay, so I think you could get away with just saying you're finding percentages of different amounts, but you know, I don't know. I think that's a bit wishy-washy. But anyway, I've done it full. You do it. You do you. Work out the correct percentage loss. So what is the correct percentage loss? We want to do a percentage change question, don't we? Again, back to my final original multiplier, little triangle thingy. Okay, now this time we know the final. That's the amount that we got in December. That was 1,320. And we know the original. We've got 1,500. What we want is the multiplier. We don't want it is. We want to know what it is. Okay, so covering up the thing we want to find. We want to find the multiplier. So multiplier equals final divided by original. Multiplier equals final over original, which is 1,320 divided by 1,500. What is that? Calculator, what is 1,320 divided by 1,500? Apparently that's 0.88. Now 0.88 as a decimal is the same thing as 88% as a percentage. That's not the answer though, is it? Because we want the percentage loss. So if you think about it, we started with 100% and we've gone to 88%. So that is a 12% loss. Okay, because we've decreased by 12%, haven't we? 100% take away 12% is 88%, which is what's happened. So we have done a 12% loss here. Solve 3x minus 5 is greater than or equal to 10. Show your solution on the number line. Well, if you know how to solve an equation, you should also know how to solve an inequality because the method is exactly the same. Now, if I'd had 3x minus 5 was equal to 10, so it's an equation, then what you do is you do the same thing to both sides, don't you? So, and try and get x by itself, and that's exactly the same thing you do with inequalities. So here I've got 3x minus 5 on the left-hand side. I want to get x by itself. So first off, I'm going to add 5 to both sides. So it's going to cancel out with that 5 there. Leave me with 3x on the left is equal to 15, and then divide by 3, divide by 3. I'm going to get x is equal to 5. But it wasn't an equation, it was an inequality. But we solved them exactly the same way. So instead of having equal signs down the middle, just going to have a greater than or equal sign. And it's still true all the way down. Okay, so my final answer is x is greater than or equal to 5. Okay, now how do I show that on a number line? We need to put a circle at that value 5. Okay, now whether or not you have an open circle or a filled circle depends on the sign itself. If it's greater than, I'm going to have an open circle like that, because the 5 itself would not be a solution. If it's greater than or equal to, then that circle is filled in. Okay, and then I put an arrow in the direction that my solutions belong. So here I want all the values that are greater than 5, so it's in this direction. Okay, so it looks like that. Solid circle at 5 and an arrow pointing to the right. Amrit's income is 32% more than Bethan's income. Amrit and Bethan's combined income is 54,868. Calculate Amrit's income. Okay, so let's call, this is, well, it's a bit of an algebra question, this, isn't it? So we've got Amrit's income and we've got Bethan's income. Now we're told that Amrit's income is 32% more than Bethan's income. So if we say that Bethan's income is X, then Amrit's income is 32% more than that, isn't it? Okay, so if we say that Bethan's income is 100% and we add on 32%, we've got 132%. So Amrit's income is 132% of Bethan's income. I'm going to write 132% as a decimal number, which is 1.32. In other words, Amrit's income is going to be 1.32x. Okay, so Amrit's income is 1.32x and Bethan's income is x. So their combined income then, adding those together, is going to be 1.32x plus x, which is 2.32x. Okay, so their combined income is 2.32x, and we're told that their combined income is 54,868. Okay, so 2.32x is equal to 54868. So now this is just an equation in x we can solve, isn't it? So if we divide both sides by 2.32, it's going to leave us with x, isn't it? X is equal to, what's that then? Grab the trusty calculator and find out. 54,868 divided by 2.32. I make that 23,650. Now that's going to be Bethan's income, isn't it? Because her income was X. So 23,650. Now we want Amrit's income, which is 1.32 times 1.32 times X, isn't it? So Amrit's income is going to be X 23650 times by 1.32. What's that then? That comes out to be 31,218. Okay, so that's my final answer. 31,218. Wow, that's 5 marks. Amazing. Jacob, Amelie, and Ruben each roll a fair 6-sided dice. What's the probability that all 3 roll a number less than 3? Give your answer as a fraction in its simplest form. Okay, so what's the probability that all 3 roll a number less than 3? Well, what's the probability of rolling a number less than 3? So what's the probability of rolling less than 3? So that's going to be, well, how many outcomes are there that are less than 3? When I roll a dice, I can get 1, 2, 3, 4, 5, or 6. And which one of those are less than 3? It's 1 and 2, isn't it? 3 is not less than 3. So there are 2 outcomes out of 6 outcomes which are less than 3, which simplifies to 1/3, doesn't it? Okay. So what we want, though, is the probability that all 3 roll a number less than 3. So what we have to do then is probability that all 3 less than 3. Well, if they all roll less than 3, that means Jacob rolls less than 3, and Amelie rolls less than 3, and Reuben rolls less than 3. Now you can use in probability a bit of a shorthand that if you can construct your probability using the word and, like it is here, Jacob and Emily and Reuben all roll under 3, then you need to multiply. So and in probability is multiply or is add. So here it's going to be the probability that Jacob rolls less than 3 multiplied by the probability that Amelie does multiplied by the probability of Reuben doing so. Okay, so a bit of a shorthand. And means multiply, and or means add in probability generally. Okay, so that's a kind of a handy little thing to remember to simplify things down a little bit. So 1/3 times 1/3 times 1/3, that is 1/27 then, 1/27. The diagram shows 2 rectangles A and B. Got rectangle A here, it's got sides 25 and 12, and I've got rectangle B where I don't have any sides for it. It says rectangle A has width of 25 and height of 12. Well, that was in the diagram. The width of rectangle B is 3 times the height of rectangle B. The area of rectangle A is equal to the area of rectangle B. Find the perimeter of rectangle B. Okay. Let's go through this line by line and add information to the diagram as we go along. So the first line of it says rectangle A has a width of 25 and a height of 12. Now that is already on the diagram. It's here and here. Okay, now the next line says the width of rectangle B is 3 times the height of rectangle B. Okay, so we don't know the width or the height, but we know the relationship between them. In that case, we can use some algebra. So if the width is 3 times the height, then if I make the height x, then the width is going to be 3 times that. It's going to be 3x, isn't it? Okay, so I'm going to have x and 3x. And then finally, I've got the area of rectangle A is equal to the area of rectangle B. Okay, so this area in here is the same as the area in here. But what is the area in rectangle A? Area of A is going to be, well, the area of a rectangle is just base times height, isn't it? So 25 times 12, what's that? It's going to be 300, isn't it? 300 centimeters squared. Okay, so that means if A is 300 centimeters squared, then so is B. And we can see that our two things multiplied together, 3x and x, are going to be that area then, isn't it? So for area B, the area of a rectangle is base times height, which is 3x times x, which is 3x squared. And we know that's going to be the same as rectangle A. So that's going to be equal to 300. So in another question where we form an equation in x and we can solve it, dividing both sides by 3 to start with. So it's going to give me x squared is equal to 100, making x equal to 10. Okay, so then that means this rectangle is 10 by 30 then, isn't it? Okay, so if the rectangle B has length and width 10 and 30, then the perimeter of B is going to be 10 plus 30 plus 10 plus 30 then, isn't it? Okay, in other words, it's going to be 80. What's the units? Just flat centimeters, isn't it, for perimeter, because it's just a distance. So perimeter B is going to be 80. Ooh, another 5 marks. Nice. K invests £1,500 in an account paying 3% compound interest per year. Neil invests £1,500 into an account paying R% simple interest per year. At the end of the 5th year, K and Neil's accounts both contain the same amount of money. Calculate R. Give your answer correct to 1 decimal place. Okay, so we're going to have to start with K because K we've got all the information for, isn't it? She's investing £1,500. It's 3% compound interest, and it is for 5 years. Okay, so with percentages, I use a triangle to remember which way around to do it. Final, original, multiplier, and I work out what I've got. Final, original, multiplier. What are my values? Final is the amount you get after the interest has been applied. Original is what you started with. So final is what I'm trying to find. Original is 1,500. Multiplier. Now, with percentage increase questions, we always start with 100%. So if I'm adding on 3%, then I've got 100% plus 3%, which is 103%, which is 1.03. It's a multiplier. Okay. What do we want? We want to find the final. So let's cross that out, and that tells me what to do with the other two. Final equals original times multiplier. Final equals original times multiplier. But with compound interest, we need to add one extra thing to this. We need to add number of years. So we take multiplier and we raise it to the number of years that we're applying this interest, because we're applying 3% interest, then 3% interest, 3% interest 5 times over. That's why we're applying the multiplier 5 times. So let's sub in the values that we know. The original amount was 1,500. Multiplier is 1.03, and the number of years is 5. Okay, so tap that into the calculator. So 1,500 times 1.03 raised to the power of 5. That comes to 1,738 and 91 pence. So £1,738 and 91 pence. Okay. Now we're told that's the same amount that Neil ends up with after 5 years, but he has been receiving what we call simple interest. So he's just going to get the same amount each year over 5 years. So if we work out what percentage increase Neil got in that 5 years, and we divide it by 5, then we should know how much interest he earned each year. Okay, so how much interest was earned in that 5 years as a multiplier? Okay, so I'm going to do another calculation. Final, original, multiplier. Now this time I know the final amount. It is Neil's final amount of money, which is 1,738.91. I know the original amount. It was how much he invested to start with, which is 1,500. This time it's the multiplier I'm trying to find, isn't it? Because I want to know what interest he received on his investment over the 5 years. Okay, so covering up the thing that I want, M, that tells me that multiplier is equal to final divided by original, which in this case is going to be my 1,738.91 divided by 1,500. Okay, now I've still got the full calculator value in my calculator, so I'm just going to divide that actually, so I don't lose accuracy. So just going to press divide 1500. Okay, that comes out to 1.159 equals 1.159. Now that's a decimal, isn't it? Okay, which is what as a percentage? That's going to be 115.9%. Okay, so if he started with 100%, he ended up with 15.9%. Then that means he's going to have a 15.9% increase over 5 years. So in 1 year, it's going to be 15.9 divided by 5 then. Okay, and again, I'm just going to use my full calculator to work this out. I'm going to take away 1, just to get the percentage, and I'm going to divide it by 5. Okay, so that comes out to be what, 3.2%? 3.2%. Correct to 1 decimal place. Okay, question 24. In this question, all lengths are in centimeters. Here is a square. It doesn't look like a square, does it? Because we've got these different amounts here. So this is a different amount to this one. But if it's a square, then they should be the same, shouldn't they? Find the length of one side of the square when b is 4. Okay. Now we're going to use the fact that it is a square. Because if it is a square, then this length got to be equal to this one, isn't it? They're the same thing. If they were different, it wouldn't be a square, it'd be a rectangle. And because it is most certainly a square, because it says it's a square, those things must be the same, even if they look different. So 4a plus 2b has got to be equal to 6a plus b minus 1. Okay? So what we've done here is we've formed an equation in a and b, and we're going to go on and solve it. So 4a plus 2b equals 6a plus b. Let's just collect like terms together. I think I'm going to collect the a's on the right and the b's on the left because I just want to keep everything positive, I think. So I'm going to take b away from this side. I'm going to take b away from this side. That leaves me with 4a plus b is equal to 6a minus 1, and then I'm going to take 4a away from both sides just to simplify this thing down a little bit. That's going to cancel with that, and this is going to leave me with b is equal to 2a minus 1. Okay, that's a kind of more simple version of what we had up there, isn't it? Right, now it says find the length of one side of the square when b is equal to 4. Okay, so when b equals 4, that's going to simplify things down even further, isn't it? So b is 4, so that means 4 is going to be equal to 2a minus 1. So adding 1 to both sides, I'm going to get 2a is 5, and then dividing both sides by 2, I'm going to get a is equal to 2.5 then, aren't I? So a is 2.5 when b is 4. Okay? So find the length of one side of the square when b is 4. Now we found the length of a. That isn't the length of one side, is it? So we have to go back and find L, the length of one side, which is 4a plus 2b, which is now going to be 4 lots of 2.5 plus 2 lots of 4. Yeah, because we were told b was 4, and we just found that a is 2.5, so that's where we've subbed it in. So we've subbed 2.5 in for a, and we've subbed 4 in for b. Okay, so let's just work that out now then. So 4 lots of 2.5, that's 10. 2 lots of 4, that's 8. Add it together, and what do you get? You've got 18. 18 what? Centimeters. It tells me at the top of the question up here, look, they're all in centimeters. So that's 18 centimeters is my answer, and with that we are done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.